Okay. So the key with these ones, and you probably will have noticed that it's cubic yards to cubic feet. So what you need to do here is you start just like before, okay? But here's the kicker. If you deal with, if you deal with yards first, I want to get them to feet. So I know that I'm going to start off with this one. 1 yard has 3 feet. But can you cancel these two? You can only cancel this 1 yard with one of these yards. How many yards are there technically? 3, right? There's technically 3. So this is how I do it, okay? Watch. I raise this whole rate to the power of 3. That's the kicker there. It's coming back in grade 12 applied, so I just wanted to kind of introduce that already. Okay, and what that does, let's leave it like that for now. So this is now a cubic, let me rewrite that. I'm going to say that this is now 35 cubic yards over 1 hour times 3 cubed is 3 times 3 times 3 is 27. And it's actually cubic feet. This power, do you remember in IPR, like the exponent rules, when you did that exponent applies to everything inside the brackets. So this applies to that, this applies to this applies to the 1, which is just 1, right? 1 to the anything is 1. So I'm going to make this 1. And the 3 also applies to the yard. So now you're in cubic yards. So you've basically cubed everything. Okay. And now you can cancel this here with this, and you're left with cubic feet, which is exactly what you want. I still need to take my hours to minutes. So I'm going to do that here. 1 hour has 60 minutes. And so cancel the hours and the hours. And so it's 35 times 27. And you will divide that answer by 60. So 35 times 27, I'm going to hit enter, and then I divide all of that by 60, so that's 15.75 cubic feet per minute. Does that make sense? So you can't just go, oh yeah, yards and feet, I'm going to cancel them out, because they're kind of the same, but they're not. The exponent, right, is very important, right, that the units match exactly. Next, 600 square feet over 1 minute. I need to go to centimeters squared. So this one is probably going to be a little bit more challenging. So I'm thinking here, I'm going to go feet to meters and then to centimeters. But let me see if I can just do a little cheat here. I'm going to go to my rates, yards and meters, right? Can I just multiply this by 100 and then get that in centimeters and then have like yards connected to centimeters? Would that be okay to do? Because 1 meter has 100 centimeters, right? So I will introduce this one here for you. 1 yard has 91.44 centimeters. This is way at the beginning, front page. So you're saying the same thing. One is just in centimeters and the other one is in meters. So, right, it saves us a little bit of time. I feel like I'm not going to have enough room to fit the steps, right, all those rates individually, because you could have gone yards to meters and then meters to centimeters, but it's too much work. Got it? We're going back to that page now. So let's see if I remember. What did I just do? I went yards and meters, right? That doesn't really help me, does it? I meant to do this one here. I'm going to do the exact same thing. It's Monday, guys. You got to give me a little bit of a break. There. 1 foot has, so I'm going to multiply that by 100 as well. And then I get that 1 foot is 30.48 centimeters. That's the one that I'm going to use now, actually. Now we go back. 30.48, remember that? 1 foot has 30.48 centimeters. I need to match the unit. So what am I going to do to this whole thing? Square it. You guessed it, right? And I'm going to go ahead already and also take care of the minutes because I needed to go to hours, right? So I'm going to go 1 hour down here has 60 minutes, and I put the minutes in the numerator because I wanted to cancel out with these minutes here. So cancel that. I can just cancel out, and I will do one more line, and this will be a little. So I'm going to square that 30.48. So that's 929.0304 squared centimeters over square foot times 60 minutes. 60 over 1 hour because I got rid of the minutes already. Okay, so then I'm just going to multiply these two. Answer times that. And then I multiply that by 60 yet, right? So it's basically this times this times this, which is and I am the square feet cancel out too, right? So I am in centimeters squared per hour. This may show up from time to time a little bit, but not a whole lot. So you don't need to sweat it too much. If you were able to convert everything else so far, you are in pretty good shape, okay? But I wanted you to start thinking of this. Let me just make sure I do this. Why don't you start thinking of that, because that's coming back grade 12 applied, this concept where you're converting not just linear, you're also converting areas and you're converting volumes, okay? So I hope that didn't throw you off too much. Yeah. And homework? Homework, okay. 2C. Okay, yeah. So miles per gallon, and you wanted liters and 100 kilometers, and you see the stars there, right? That usually tells you, dun, 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 right? Like there's something there. So what I'm going to do first is I'm going to focus and figure out what it would be liters per kilometer first. Liters per kilometer. So I'm going to go 18.5 miles in 1 gallon. That's, I don't know if you know MPGs, if you know your cars, right? That's how many miles you can travel in in 1 gallon of fuel that you put in the tank, right? That's how they kind of measure fuel consumption of a vehicle. So that's how many miles in 1 gallon. And I'm going to go tackle the miles first, get it to kilometers. So 1 mile has 1.6093 kilometers. Is that right? Yeah, I got it. Okay. So So miles and miles. And then I'm going to tackle the gallons. And I know that 1 gallon, because I need it to be in liters, right, has 3.79 liters. And just hold it for now, just follow my lead here. So at the end of the day, I have kilometers and liters, right? That's what I'm focusing on. So I'm going to figure out what that is. 18.5 times 1.6093. So that would be 29.77205. What are we at the top? It's kilometers. And then the denominator is 1 times 1 times 3.79. That's just 3.79 liters. And at this point, I use this and use proportional reasoning to get me to figure out what it is per 100 kilometers. Because I just find that easier. So once you have it in the units that, right, these two units appear in my final answer, right? So that was my first goal. I want liters and I want kilometers, right? And now, and I kind of used up too much space here, but I'm using this 29.77205 kilometers for 3.79 liters, okay? And then I put on the other side, I'm going to say, well, how many liters, right? How many liters would I need to travel 100 kilometers? Right? So I basically set up a proportion. And when I solve for x, right, then I figure out how many liters per 100 kilometers were required to travel. Does that make sense? So I wanted there to be a bit of a curveball just so you start thinking. I will often switch from converting to now it's like, well, okay, if this is true, what would it be on a different scenario? It could have asked you like how many liters for 1,000 kilometers, right? Could have asked you that, right? So you still go about using proportions. I'm gonna completely take up the space here. So it's 100 times that, right? So x would be 100 times 3.79 divided by 29.772, and I'm just going to go dot, dot, dot there. I'm very okay with that because I'm assuming you're using all decimals. So it's really 379 divided by that previous answer. So that's 12.73. Does that match the answer on the key? What was the answer in the key? Wasn't it 16 something? So do you think I made a mistake or what? Yeah? I probably did. I'm just gonna check here. I hope, like, if that's what threw you off. Is that what threw you off with this question, the answer? My bad, guys. So are you getting this? What were you getting this when you tried it? Or not? You didn't get that far? Okay. Does it make sense when yeah. I'm just checking my answer here. Did I flip this by mistake on my key? I think that may have happened. So I have to fix that. Definitely have to fix that. So the answer is 12.73 liters per 100 kilometers. My bad. From time to time that will happen. Feel free to tell me that I made a mistake. And then if you made a mistake, then I'll tell you back you made a mistake. How's that? In a nice way. You know what? I 100 times prefer you trying, making a mistake, than not trying at all and not knowing whether or not you're on the right track. Right? So if you try, if you make a mistake, not a big deal at all, as long as you're trying. Okay. We're good? Any other questions? Okay. All right, let's go back to our yellow booklet. And I'll make sure I fix that on the key. So we're going to go to page 4 here. And I didn't check, but if you would be able to fill out the questionnaire, the Welcome to Sisler questionnaire, and just upload it on Google Classroom, I would appreciate that. And once I have most or all of them, I'll start reading them. Helps me remember your names. So we're going to look at solving problems. Maybe I will just stop this